In our previous video, we had a look at some of the foundations of trigonometry, and here are some of the things that we drew on in that video. We specifically looked at what we learned in grade 10, but here are some things that we will pull through into this video for today. Okay, the first thing is we started with trig in right angled triangles, and we had our ratios sine, cos, and tan. And then in grade 10, we learned that we can actually apply this right angled triangle onto the Cartesian plane, and we can express these same trig ratios now in terms of x and y coordinates and r values, as in a radius line. And then something that we didn't touch on in our last video, but we did learn about in grade 10, is this thing called the cast rule. So we learned that in quadrant 1, all of the trig ratios are positive. In quadrant 2, sine is positive, but cos and tan are negative. Okay, in quadrant 3, the t there represents tan, so tan is positive, but sine and cos will be negative. And finally, in the last quadrant there, we've got cos is positive, and then sine and tan will be negative. Now, there are lots of interesting ways that you can prove this. You can have a look at a sine ratio, for example. Sine is y over r. In that third quadrant over there, y would be negative, and r is always positive. So you've got a negative divided by positive, which does give you a negative. Okay, so cast rule was important, but this year we're actually going to build on that cast rule. Have a look at this Cartesian plane here. If we were to travel around, now trigonometry always works in an anti-clockwise direction, and we start here on the x-axis. We'll start at 0 degrees. Then we'll travel around, we'll get to a 90-degree line, we'll go around to a 180-degree line, and then a 270-degree line. And finally, if we go all the way, we'll end up at 360 degrees. So we can travel in a full revolution there, and we'll end up working our way through every single quadrant, okay? But it's helpful to know that when we are referring to these different quadrants, they've got names. So we've got quadrant 1, quadrant 2, remember I said it always goes anti-clockwise, quadrant 3, and quadrant 4. You don't have to use Roman numerals for this, but they often do when they refer to these quadrants. So it's just good to recognize it from our grade 8 days when they taught us how to read the basic numbers. Okay, and now if I want to refer to an angle, specifically in quadrant 2, what I do is I link it to what is happening on the x-axis. So the x-axis here is coming up from the 180 degrees line. So we call this our 180 degrees minus quadrant. You're working backwards there, okay? If I want to refer to something in quadrant 3, I'm then moving bigger than 180, and so that we'll call the 180 degrees plus quadrant, okay? And if we move then over to quadrant 4, we want to link it again to the x-axis, okay? Our next video will just discuss briefly what happens when we link something to the y-axis, but generally when we do reductions, we try our best to stick with the x-axis, okay? So the x-axis there will be all the way around to 360 degrees, so that's our 360 degrees minus axis, okay? And on rare occasion, some people refer to this one here as a 360 degrees plus quadrant, but essentially that could also just be 0 degrees plus. So there it is, nice and neat. Quadrant 1, 360 degrees plus. This theta is a placeholder for any kind of acute angle, okay? Quadrant 2, 180 minus. Quadrant 3, 180 plus. Quadrant 4, 360 minus. And now we're going to combine something that's written like this and then determine whether or not it'll be positive or negative. So here are a whole load of these for us to practice. In this instance, we don't know what theta is, but it generally represents some sort of acute angle, okay? And this whole process is called reductions. So they want us to reduce something that's written all big like this into a simple one-term answer, Okay, so sine of 360 degrees minus theta. 360 minus, that's down here in quadrant 4. And we have a look at the cast rule to tell us whether or not sine is positive or negative there. So according to this, C for cos is positive here, which means that sine will be negative in that quadrant. So we can reduce this then to minus sine of theta. Okay, so you'll notice that I'm no longer writing the 360 minus. That just helped me to find the quadrant, and once I found the quadrant, I could decide whether it was positive or negative. Okay, next up, cos 180 degrees minus. So 180 minus, that's here in quadrant 2. We're dealing with cos. Is cos positive or negative there? Well, only sine is positive, so that is going to reduce then to a negative cos theta. Tan in the 180 plus quadrant, that's down here, quadrant 3. And in that quadrant, tan is positive. So that's going to reduce to a tan theta. Okay, here's one with 2 that are being multiplied. So tan of 180 minus theta, that's this quadrant here. Only sine is positive, so that's going to reduce to a negative tan. Okay, you'll see I've straight away popped a bracket in because it's multiplying by the next thing that I'm going to reduce. So be careful there. You don't have to put a bracket on that first term, but it's very good habit to put brackets in whenever things become negative and you're dealing with more than one term or more than one trig ratio that you need to work with. Okay, tan in the 360 degrees minus quadrant, that's quadrant 4. Cos is positive here, which means that tan is going to be negative there. Okay, and then this just becomes a simple multiplication. Minus times a minus is a plus. Tan times tan is tan squared. Okay, so tan squared theta. You could also write this, but it's not very common, as tan theta, and then you square that whole thing. Okay, but generally we pop the squared in over there. Now let's have a look at what happens to negative angles or angles that are very big, like bigger than 360 degrees. So here we're given what looks quite similar to what we just did. Simplify, minus 180 plus theta, and then there tan 900 plus theta. So we want to apply our cast rule. So what you should notice straight away is that there is no minus 180 plus theta quadrant. Okay, and they love to sneak this one in and write it back to front. Theta minus 180, and a lot of students get confused there and think that's a quadrant 2. Okay, but it isn't. This is something that we're going to have to figure out. Okay, so if we look at this Cartesian plane here, we want to figure out how to deal with angles that are negative. So this one here is considered a negative angle, and this one here is very big. Okay, neither of these fits on the Cartesian plane as we know it right now. But because this is cyclic, if I were to move a full 360 degrees, I would end up exactly where I started. And so what I'm allowed to do is for an angle like this first one, where it's negative, I'm allowed to rewrite that then and say, well, this is going to be cos of minus 180 plus theta plus 360 degrees. It's kind of like multiplying by 1 because all I'm doing is going all the way around, ending up at exactly the same place, but I've added 360. And then if we group these like terms here, we'll see this actually simplifies to cos of 180 degrees plus theta, which is there in quadrant 3. And in quadrant 3, 180 plus, tan is positive, which means that cos is negative. So minus cos theta would be the final answer there. Okay, and in the same way, this tan of 900, now I'm sitting with something very big. So I actually want to work backwards and minus 360, and let's see where we end up there. So we're going to say 900 minus 360, and we end up there at 540. So we can rewrite this then as tan of 540 plus theta. Okay, but 540 is actually still too big. Our Cartesian plane goes up to 360. So we're going to have to do it again. So let's go 540 then minus 360. And we end up there with 180. So 180 plus theta. Okay, that's here in quadrant 3. Tan is positive there. and so that simplifies to tan of theta. Okay, so if ever you are given a negative angle or a very big angle, remember that you can add 360 or subtract 360, and technically, because you've gone in a full circle, you have not changed the question at all. Now we're going to combine reductions with special angles. So the question says, simplify without the use of a calculator, and that is usually one of my big clues that I'm going to need to use special angles. Now the last questions that we looked at, or the last examples that we looked at, we're dealing with unknowns like theta. But in this case, we actually have the full angle, okay? But the fact that they told us no calculator means we are going to have to be crafty about how we solve this. We need to get them to be one of these angles here that we know the answers to. Okay, so the first thing I need to do is I need to say, where is 135 on this Cartesian plane, okay? And 135 is somewhere here between 90 and 180. Remember, we know that each of these represents a specific angle. So it's somewhere there in quadrant 2. And so I can then rewrite this as sine of 180 degrees minus something. So sine 180 degrees minus 45 will equal this thing that I'm working from. That equals 135. So I've now done my first step of the reduction. And now I can say, is sine positive or negative in that 180 minus quadrant? And it is positive. So that is equal to sine of 45. And that's a special angle. Sine, we know, is y over r. So on this 45 degree line, y is root of 2, r is 2. So that will be my final answer, root 2 over 2. Okay, so I just identified the quadrant. We're going to do the same thing here with this tan squared. Okay, tan squared of 300. So 300 is somewhere here between 270 and 360. Okay, so I need to write it as 360 minus something. So that's going to be tan squared of 360 degrees minus how much gives us 300? That's 60. Okay, is tan positive or negative there in that fourth quadrant? According to the cast rule, only cos is positive there. So this is going to end up being minus tan of 60 degrees. Okay, and that's squared. And so a lot of students, if you're confident, you can actually say, well, I already know a minus times a minus is going to go away. It is up to you, or you can write the minus in there. Just be careful. It's only when it gets squared that you have that luxury. Okay, tan of 60 degrees, well, tan is y over x. There's our 60 degree line. So root 3 over 1. So I'm now going to substitute that in. Minus is there, root 3 over 1 squared. And then when I work that out, it's just going to give me a nice little 3. Okay, because the minus times the minus is a plus. Root 3 times root 3 is 3. And then over 1 we don't need to write. Okay, finally we've got one that's a little bit more complex, but it's definitely something that we can do. Okay, first thing that I'm noticing is that not all of these are nice and special like the sine of 30. Okay, so that one's ready to go, but the rest are not. Another thing that I like to look out for is negative angles. So this one we're going to have to plus 360, and big angles we're going to have to minus 360. Okay, so try and stay on high alert for those. What's nice about that cos there where we add 360 is it straight away actually shows us which quadrant we're in. So we could work it out, get to cos of 300, and then go and put it in quadrant form, but we can actually just take a shortcut and say this is going to be in the 360 minus 60 quadrant. Okay, so let's rewrite that first step. Sine of 30 is fine, times cos 315 degrees is somewhere here, so we can rewrite that then as 360 degrees minus 45. That gives me 315. Then plus cos of 360 minus 60 times sine. If I take that 405 and I minus 360, I actually just end up with sine of 45. So that one's nice. It's already reduced there into quadrant 1, a nice acute angle. Okay, next up we're going to say, okay, sine of 30 is still fine for now. I'm going to get to those special angles, but let's sort out these causes first of all. is cos positive or negative here in this fourth quadrant? Okay, they're both 360 minuses. So cos is positive there. So I can then say, well, then that's just times by cos 45 plus cos of 60 times by sine of 45. Okay, now I've got loads of special angles here. Let's substitute them. Sine is y over r. There on the 30-degree line, that's going to be 1 over 2. Cos of 45, cos is x, root 2 over r, 2, plus cos of 60 on the 60-degree line, cos is 1, x over r, 2, multiplied by sine of 45, that's y on the 45-degree line, over r. Right, so that's going to give us root 2 over 4 plus root 2 over 4, which becomes 2 root 2 over 4, and that can actually simplify. 2 goes into 2 once and into 4 twice, so we end up there with a nice little answer of root 2 over 2. Okay, most of your teachers actually don't mind if you use your calculator here a little bit to guide you to get to this final answer, but make sure that everything that leads up to that is done without the use of a calculator.